You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Space missions you should know. You know all about the Apollo missions that landed on the moon. You know all about the Hubble Space Telescope that's brought us much of our best knowledge about deep space. And you're certainly a huge fan of Spirit and Opportunity, the twin Mars rovers designed to survive 90 days, but one of which, Opportunity, has already exceeded its lifespan by nearly 13 years and is still cranking along. You've proven that you're a fan of our various space programs, so today I'd like to list a few that are of particular note. Hopefully one or more of these might be new to you. First, I'd like to start with some vintage missions, landers and probes from yesteryear in danger of being forgotten. Then we'll move on through the present day and into the future, but we'll get our start in those greatest days of skinny ties and slide rules. Luna. For almost 20 years, the Soviet Union's Luna program sent probes and rovers to the moon. Of 24 missions, 15 were successful. The first of these, Luna 2 in 1959, was intended to do no more than impact the moon's surface, which it did, becoming the first man-made object to reach the moon. But more importantly, it sent back valuable measurements of the Van Allen radiation belts. Luna 3 sent back humanity's first photographs of the far side of the moon in 1959. Luna 9 became the first Earth probe to soft land on another celestial body in 1966. 3 Luna missions in the 1970s soft landed and incorporated scoops that collected moon rocks, then blasted them back to Earth, where they successfully parachuted to safety. But perhaps most impressively, 2 Luna missions, in 1970 and 1973, carried the LunaCode rovers that explored a combined 47.5 kilometers across the surface, farther than the Apollo astronauts were able to cover in their lunar rover. Venera. It was the Soviets again striking first on the planet Venus, with their series of Venera landers throughout the 1960s, 70s, and 80s. The extreme temperatures and pressure make landing on Venus a Herculean achievement in itself. Venera 9 and 10 both landed in 1975, and each lasted about 1 hour before literally melting. It was 480 degrees Celsius, about 900 Fahrenheit, with atmospheric pressure 90 times that on Earth. Each sent back a single photograph of the surface, which, considering how much tougher the conditions are than on Mars, kind of blow your mind just to look at. Pioneer and Voyager. Always keep in mind that, as a human on Earth, you currently have 4 robotic representatives reaching out beyond the solar system, headed for other stars. Pioneer 10 and 11, launched in 1972 and 73, explored Jupiter and Saturn, and are currently out beyond the orbit of Neptune, headed into interstellar space at a speed of about 2.5 astronomical units per year. They each carry a copy of a gold anodized plaque depicting human figures and some diagrams explaining where Earth is, designed by Carl Sagan and Frank Drake, in the hope that some aliens might eventually find it. The plaque was notable for causing controversy among many at NASA for showing line drawings of naked people, which some felt was obscene. Voyager 1 and 2 followed in 1977 and are also beyond the planets and headed on one-way trips to other worlds, a bit faster, both traveling at about 3.5 astronomical units per year. Sagan also chaired the committee that decided the contents of the golden records that both Voyager probes carry. These records contain a wide assortment of music, sounds, spoken words, and pictures from Earth. Instructions printed on the record show how to play it, and at a speed given in terms of the time it takes for hydrogen to transition from one state to another. It's one of my favorite examples of the glory of science. How all intelligent beings are connected through our ability to decode the natural world, across interstellar space, even across galaxies. Cassini. One of our greatest gifts that keeps on giving is the Cassini probe orbiting Saturn. It launched in 1997, entered Saturn's orbit in 2004, and in 2005 it did its biggest trick, dropping the Huygens lander onto the moon Titan, an icy, rocky world with oceans of liquid methane. Huygens had a short lifespan of only a few hours, but sent back a photo from the surface, and plenty of data. The amount of science that has come back from Cassini over more than a decade in orbit would fill entire libraries, and even for me to limit it to just a few of its most impressive discoveries for this podcast would require about a week. Just think of the high-resolution photos and radar maps of Saturn's major moons, close study of Saturn's north polar hexagon, the famous rings in unprecedented detail, and perhaps most significantly its discovery that water geysers on the moon Enceladus are brimming with organic chemicals, tantalizing proof that complex chemical reactions take place in soupy water below its surface. Cassini has done about all it can for us and is currently scheduled to enter Saturn's atmosphere in September of 2017 for a grand finale goodbye. Rosetta. In September 2016, the European Space Agency probe Rosetta ended its career with a death dive into Comet 67P after orbiting it for 2 years, following an impressive 10-year odyssey to get to it. On arrival, it dropped its lander Philae onto the comet. Unfortunately, Philae landed awkwardly on some boulders at the base of a rocky bluff and couldn't do much of what it was supposed to. But Rosetta got a really neat photograph of its predicament. One of the most important of Rosetta's discoveries is that the water on 67P is significantly different isotopically from water on Earth, casting doubt on the theory that much of Earth's water may have originally come from comets like this one. When the time finally came, Rosetta pointed its camera down at the surface, fired its motor for 208 seconds, and assumed a grim facial expression. The photo stream from that 14-hour fall to oblivion became one of the great science moments of 2016. Dawn. Launched in 2007, Dawn took almost 4 years to reach Vesta, the second largest dwarf planet in the asteroid belt, where it entered orbit and made the first real surveys. It then left and took almost 3 years to reach the dwarf planet Ceres, the largest object in the asteroid belt. Its most popular discovery was a number of mysterious bright spots on the surface, which turned out to be salts carried to the surface by water. Water, it turns out, makes up about 50% of Ceres by volume, which is more than we have fresh water of here on Earth. Perhaps the most notable thing about Dawn is that it is driven by solar-powered ion thrusters. Although a number of Earth satellites use ion thrusters, Dawn is the first to take the concept out into interplanetary space. An ion thruster gets its reaction from high energy rather than high mass, by electromagnetically accelerating xenon atoms to extreme speeds. The ion thruster is great for low constant thrust over very long periods of time. It would not be an exceptional choice for a dragster. Dawn's 0 to 60 time is just about 4 days. Juno. Launched in 2011, Juno entered Jupiter's orbit in July 2016 to spend 20 months characterizing the planet's interior, as well as its magnetic and gravitational fields. One of the things we want to know is how much water is deep within Jupiter's atmosphere. Unlike most deep space probes powered by RTGs, radioisotope thermal generators, which last decades, Juno carries 3 enormous solar panels. They're big enough to collect solar radiation even as far out as Jupiter, and also to provide crucial stability to the spacecraft. It's scheduled to complete its mission and deorbit into Jupiter in 2018. Why are Cassini and Juno both discarded by dropping them into the gas giants? Because the prevailing sentiment is to absolutely protect potentially habitable moons from any possible Earth microbes that might be aboard space probes. Dropping them into the gas giants is almost like dropping them into the sun. It's a leave-no-trace garbage disposal. At random, Juno carries 3 aluminum Lego minifigures representing Galileo Galilei and the Roman gods Jupiter and Juno. They will become the first humanoids to die inside a gas giant. InSight. This Mars lander is currently scheduled for a 2018 launch. Its science packages are intended to give us an unprecedented look into the interior of Mars, including the size and makeup of its core and mantle. It's going to plant a seismometer on the surface that will build detailed maps of the planet's interior using the echoes from meteorite impacts. So long as Mother Nature is setting off seismic survey charges all over the planet at no charge, why not take advantage? Another of its instruments is a temperature probe that will bury itself 5 meters underground to find out how heat radiates out from Mars's interior. The James Webb Space Telescope. Protected behind a giant 5-layered sun shield, this mother of all space telescopes is currently scheduled to launch in 2018. Its 25 square meters of collecting area is more than 5 times Hubble's. It can see in the visible spectrum, but its emphasis is infrared, as it will be looking at the most red-shifted objects in the sky, which are the very farthest and oldest. It is expected to look all the way back in time and space to the very first galaxies being formed more than 13 billion years ago. Unlike Hubble, which orbits the Earth conveniently nearby, the Webb will be 1.5 million kilometers out into space, maintaining station at the Earth's L2 Lagrange point. This gravitationally stable point is at the end of a straight line from the Sun through the Earth, far enough away that noise from the Earth is minimized, much of the Sun's light is blocked, and all 3 of the Sun, Earth, and Moon are tucked away at a single point in its sky so that everything else remains wide open all the time for observation. The downside of being so far away? Well, don't expect any manned repair missions. Spacecraft are cool for different reasons to different people. Some are impressed by the technology each uses. Some are impressed by the science each performs. Some are impressed by their amazing sci-fi accomplishments. Some are even most interested by how cool each one looks. So quite obviously, this episode has left some listeners screaming and shaking their fists because I did not include their particular favorite. If you all scream loud enough, perhaps we can do a second part. Please direct your outrage to the Skeptoid accounts on Twitter and Facebook, or even email me at brian@skeptoid.com. And let's see if I succeeded in outraging a good percentage of you. If I did, at least it's for a great reason. Cool space missions. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.